Hi everyone. If you want to increase your dimensional accuracy, but also have better fitting of your laser cut part, this video is for you. The problem is called kerf, the little amount of material which is burned away while the laser is cutting. Today, I'm going to explain you how to measure it and to set the composition in the XTool software so you have better accuracy and better fitting of your part together. These settings made a huge improvement in my project, and now the parts are more accurate and better fitting. So what is the kerf? The kerf, as you can see on the XTool documentation, is the material you actually remove from your material when you actually cut. And that is like a hand saw or a mechanical saw or anything like that. The laser doesn't do anything else. It actually burning some materials away, so it actually makes a cut. It's a really simple process. In the case of getting dimensional accuracy, the kerf is the first step we need to calibrate to be able to have higher accuracy. And to be able to do that, we need to know the width of the kerf that we have when we are actually processing. And it says on this page, it's actually the XTool blog academy, that this is depending on the type of laser you have, on the type of material you have, on the speed, the power, etc., and also on the thickness of the material. So it's not one value fits all. You would have to repeat this process a few times if you change type of materials, or if you change, for example, if you have a 10 watt laser or 40 watt laser, whatever, it will actually change the kerf size. So just keep that in mind, that it's not value for everything. And you would have to redo it from different type of material. So how to actually do the measurement? Well, first of all, you need to be able to cut something. So let's say that I am working with some 3mm plywood and I want to make a cut of something. So I just do, let's say, 100mm by 100mm parts, and I put it somewhere on the plate and I cut this part, and I just make sure that I set something realistic in the cut. In my case, my system is working pretty well on 100% at 13. So I set that, and you have this amount. And of course, you don't set anything on the Kerf Offset. You can see it's actually set to 0 because we want to measure it. So what is going to happen is where the head is going to go, like you see here, is going to follow the line. So the laser will be exactly on the line that I want to cut. And therefore is going to be remove left and right and top and bottom of this line some materials. And the objective is to be able to cut the part and measure what the outside is against the inside. And this is what we're going to do. To cut the material, I want it to be a little bit fancy, and I actually engrave on the plates both the cut and the cutout, the X and Y axis, to actually realize later on that I inverted the X and Y. So yeah, well, sometimes the brain stops working. It doesn't really matter. As long as the part is cut correctly, it's good to go for a measurement. So here is the part that I actually cut on the machine. And as you can see, it's not 100mm, it's 200mm by 200. The reason is I thought I was going to be able to do the kerf and the dimension accuracy measurement, but it's not possible. So this is just for the kerf. And what you do is you cut your parts and you actually measure it against what's the outside. I recommend to do the measurement in both directions. So you do one measurement for the x-axis, so you measure left and right, and for the y-axis, so top and bottom. In my case, the S1 has the same correction factor between X and Y, or the same curve, so it's not a big issue. But just in case that you see some differences, it shouldn't be, especially on a curve. But just in case you see some differences, you can do, for example, an average or something like that to make sure that you have the right value. So the process is simple. You take something accurate, like a digital caliper. It will not work with a linear like that because the measurement is so accurate that you won't be able to see it on this. You won't be able to get a value decent. So get a caliper, digital caliper. I mean, they're not too expensive these days. And what you do is you measure your part, whatever the dimension of the part is, and you measure then the cutout of your part, whatever you have. Make sure you do a few dimension measurement at different points, just in case. Again, the S1 should be accurate enough that it should be changing, and just to make sure that you know how to use one of these little tools to ensure that you have the right measurement. So setting up the curve in your system is actually improving the accuracy of the part because it's simply compensating the dimension from the part with the curve. But also it will allows you to have way better fitting of your parts that comes together. And this is fairly important if you want to have accurate and nice tight fitting parts, especially if the parts are cut on the same machine. Again, if you start to having parts which are from two different machines, for example, on the project that I do, where I mix 3D printing with laser cutting parts, the curve composition is not the only one you have to do. You also have to look at the dimensional accuracy of your machine, which is going to be the subject of our next video. Thank you for watching. Snafu, but learning.